So in this problem, we're asked to write y equals 2x squared plus 4x plus 5 in standard form and use properties of the standard form to graph the equation. So just to recap, remember what that standard form, anytime we have a horizontal shift at least, that standard form is going to be y equals a times x minus h squared plus k, where hk is the vertex. So there's our standard form. So how do we get from y equals 2x squared plus 4x plus 5 to this x minus h form? Not using properties, but using our the properties of the standard form itself, which is y equals a times x minus h squared plus k. Well, again, we're going to complete the square here. So what that means is we're going to factor out whatever common factor we have with the 2x squared and 4x terms coefficients. So we have 2 and 4, which means they share a common factor of 2. So we're going to take that out, and that's going to leave us with 2 times x squared plus 2x. Let's go ahead and leave a space here, plus 5. Now, how do we complete the square here? Remember, we divide this middle term by 2 and then square it. 2 divided by 2 is 1. Squared is going to be 1. So x squared plus 2x plus 1. But now remember, we have this 2 out here. So we're not just adding 1. We're adding 2 total. So that means we need to subtract that from out here. Subtract it from the 5. So now y equals 2 times, remember we completed the square, so this is x plus 1 squared. And then plus 5 minus 2 is plus 3. So now remember we said that HK is our vertex. We're going to use that here in just a second. Let's go through an order like we normally do. Here is the equation in standard form. So what is A? A equals 2, and that means the parabola opens up because A is greater than 0. So now our vertex, we said, remember, is HK. So our vertex is HK, which in this case is, remember, it's x minus h. So x plus 1 is x minus negative 1. So HK is going to be negative 1. And then K is 3. And this also means the axis of symmetry is going to be x equals negative 1. So now we'll find our y-intercept. So we'll go ahead and put this vertex out here because it will tell us something about the graph to save us some work. Negative 1, 3. We'll go ahead and put this 1 here to indicate the scale. So negative 1, 3 is right here. Now remember, A is positive, which means A equals 2 is positive, which means the parabola opens up. We're not going to have any x-intercepts because it's opening up and the vertex is already above the graph. The minimum is, above the x-intercept. The minimum is above the x-intercept in the vertex. So we're going to go ahead and find the y-intercept as an additional point. Remember, the y-intercept is when x equals 0. We can substitute that into the original form or into the vertex form. Either way, in the original form, it's 2 times 0 squared, which is 0, plus 4 times 0, which is 0, plus 5. So the y-intercept is going to be 0, 5. And if we use the standard form with that horizontal shift in there, if we substitute 0, 0 plus 1 is 1, squared is 1, times 2 is 2, plus 3 is 5, so we end up with the same y-intercept of 0, 5. So 1, 2, 3, 4, 5. Now remember, our axis of symmetry is x equals negative 1, so we're going to have another point over here at negative 2, 5. If we wanted to check our graph, We could plot a few more points to verify that they fall on the curve, or just to make the graph more accurate. So again, to put y equals 2x squared plus 4x plus 5 into standard form, y equals a times x minus h squared plus k, we completed the square with the x squared and x terms, and then simplified that to the, uh, the standard form by whatever we added to get the perfect square. In complete with x, we subtracted from the constant that was outside. And then we use the properties that we have in the past. A being positive means it opens up. The vertex is hk in the standard form of a times x minus h squared plus k. So we have the vertex, which also gives us the axis of symmetry. And then we found the y-intercept. And then another point at negative 2, 5, because of the symmetry across the axis of symmetry, to get our parabola.